Good morning, afternoon, and evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. We are still on rational expressions, and today we're going to talk about one of my favorites. It's a real puzzle. It's a real mind bender here. The complex rational expressions. Sometimes they're called complex fractions, okay? But they're complex rational expressions. So what is a complex fraction or rational expression? It is a rational expression. You know what rational expressions are. That means it's a fraction with a variable in the denominator that has at least one fraction in its numerator and or denominator. So in this one, it's going to be multiple fractions within fractions. Here are some examples of complex fractions or rational expressions. Okay, this is a rational expression over a rational expression. That's a complex fraction. This is a rational expression over a rational expression. That's a complex fraction. This is a crazy rational expression over another crazy rational expression. That's a complex fraction. So when you have a rational expression divided by a rational expression or over a rational expression, you're really dealing with complex fractions. So we did some work on this already, so this is not going to be too difficult. That's the good news. There are two methods for simplifying complex fractions. Okay? Method 1, I'm going to teach you, and then I'm going to teach you method 2. I have to teach both, and you know how I like to teach my methods. You guys are the ones that have to choose. I'm not going to be with you for the rest of your math careers, and you guys still have many years. So choose one method, learn it, love it, and live it. Just like when we did the factoring trinomials with ax squared. Remember there was the cubic method, and then we had that little box method. You guys got to choose the method you guys like. So method 1, procedures. Simplify both the numerator and the denominator individually. Well, we know how to do that already. For the numerator, just so we could keep this nice and clear, I'm going to work with the numerator in red, and I'm going to work with the denominator in blue, just so we could keep things clear. So, my numerator. What's the LCD of the numerator? So I'm doing it in red, okay, xy. So what do I need to multiply here? And what do I need to multiply here? An x. So this is y plus x over xy. Does everyone see and agree with that? Okay. Divided by, we'll do it in black, my blue. My blue is just 1 over xy, so we don't have much to do there. Now, how do I'm sorry, not now. 2, divide. What does this remind you of? A little song I taught you. Stay, change, flip. I know that's the top 40. Stay, change, flip. X, Y's cancel, so my answer is y plus x. And that part is simplify. You're done. Literally. Over. Bye-bye. See you later. Have a good day. Of course, this was nice and easy, but that's the method 1. Simplify the numerator, simplify the denominator. Divide them, stay, change, flip, then simplify. Pretty straightforward, right? Yes, sir. Thank you. Okay, what do I mean by simplify? Thank you for asking, sir. Green. Isn't there an xy in the numerator and an xy in the denominator? I canceled those out, so then I have y plus x over 1, whatever, y plus x. That's what I mean by simplify. Thank you so much. Great job, son. Way to go. We're good? Promise? Okay, method 2. Let's look at method 2 here, guys. Method 2. Find the LCD of every denominator. So what's the LCD? We're just going to do this now in one color, black, because we're doing it all together. What's the LCD of every denominator? XY. Okay, now, does everyone see that? What's the LCD of every single denominator? Step 2, distribute or multiply the LCD to all of the numerators and denominators. So I'm going to multiply xy to everything. Okay? I'm going to multiply xy to everything. And actually, wait a second. That's wrong. It's not multiply the LCD to all of the numerators and denominators. It's just multiply the LCD to the numerators. I'm sorry. Please scratch this off. That is my error. No excuses. I apologize. That was silly. Sorry about that. That was dumb. So I'm going to multiply everything to every single numerator. So this is going to give me xy, right, over x, right, plus xy over y, right, over xy over xy, correct? Okay, now let's simplify. What's xy over x? What's xy over y? And xy over xy? Done. Step 2, simplify. I particularly, I like method 1. Method 2 is nice when it's nice and easy like this, but when you got to start factoring, and you got maybe three values or 3 factors for the LCD, it gets tougher. Yes, sir, my brother. Yes, sir, my brother.
It's xy, right?
Correct, sir.
Okay, so why don't you multiply y to the numerator and denominator for the first fraction?
You don't multiply it to the numerator and denominator because, okay, if I have 1 over x and I multiply xy to both top and bottom, now I have xy over x squared y. And I don't want that. What I'm trying to do is, I'm trying to eliminate the denominators. So remember when we had fractions like this, 3/5 x plus like 1/3 was 1/10. Remember that to get rid of the denominator, we multiply the numerator by the common denominator? Do you remember that, my man? Same thing I'm doing here, bro. Same thing. Now I'm taking my xy and I'm multiplying it to the numerator because xy over x is y. I'm taking that xy and multiplying to the numerator because xy over y is x. I'm multiplying to the numerator because an xy over xy, that canceled out. These are great questions. Thank you. Method 2, some of you are going to use sometimes and some of you are not going to use sometimes. Know both of them. Me personally, I like method 1. Maybe it's just because I'm old-fashioned, I'm used to it. I don't know. But I do enjoy it. That should be a plus there. I do like method 1, but that's why we practice. That's why you go to school. You have to choose your own path. May I continue? Thank you, gentlemen. Let's just do it, guys, and then I'll be honest with you. With stuff like this, either method works. Method 2 works just as well as method 1. So why don't I do one of them in green and then one of them in red, okay? I'll do method 1. Bless you. In green, apparently. So method 1. Okay, what's my LCD for this numerator here? Okay, so what do I got to multiply to the top and the bottom here? Okay, y here, and over here? On x. Okay, so I'm going to get y plus x squared over xy. Over. Okay, down here, what's my common denominator here? Y, so I got to multiply this by a y over y, giving me 1 plus y over y. Is everyone with me, my brothers? I see some of you looking at me a little bit strange. Talk to me. Because I'm finding a common denominator. So I had 1 over 1. The common denominator is y. So what am I missing from this 1? A y. So I got to multiply y to the top and the bottom. Thank you, sir. Good question. Thank you for your honesty. Is everyone with me so far? Okay, now, last step. Stay, change, flip. Stay. We're going to divide. Change. Flip. Simplify. This y goes bye-bye with that y. Can I take these two y's away? No. You cannot take individual pieces of polynomials away. So my answer is going to be y plus x squared over x times 1 plus y. Does that make sense? Or I should have done that in green. Sorry. Sorry. Does that make sense to everybody?
Yeah.
Yes, sir. Yes, that's why xy is a monomial. This is another monomial. You can simplify monomials. You cannot simplify individual pieces of polynomials. Yes, sir. No, because this x is a monomial. This x is part of a binomial. Guys, you can simplify this any day of the week because they're both monomials. But you can never, ever simplify these two x's. You cannot. It is illegal in math. I appreciate the questions. Does that make sense to you guys? Are you sure? Because we've gone over this a lot. Please, please pay attention. May I continue? I'm going to erase it all and do it in red. I'm going to do method 2. Yeah? Okay. I'm going to leave the answer, make sure that we get the same answer. Okay. Method 2, what's the LCD of everything? Okay, so I'm going to multiply xy to everything. To this, to that, and to that. So what's xy over x? When I multiply here, xy over x. Y. Plus what's x squared y over y? X squared. Over. Over. What's xy over y? And what's xy plus 1? I mean times 1 plus xy. So now I have y plus x squared over x times 1 plus y. I did it correctly because they're both the same. It's your method. You choose. You choose. But definitely stick to one. Know how to do both, because sometimes easy ones like that I maybe would do an LCD. I'd do a method too, maybe. Sir?
You said before up at top that one works like most of the time, and like when it gets to the harder questions, it'll be like.
Yeah, method 1 works awesome. Method 2 works awesome. When you get to really more complicated ones, I'll show you some now. Sometimes method 1 is a little bit better. You have to be able to decide what's easier for you. Okay, like here, for 2. What do you think would be easier here in this case? Method 1? I would say method 2. Look, what's the LCD here? XY. So multiply to that, and to that. So I got x squared y over xy over x plus xy over y. So that's going to equal x squared y over y plus x. Done. Or, let's do it method 1. I'll do it in blue over here. Method 1. X is the numerator, no worries. Okay, I got xy here, so I'm going to multiply a y to top and bottom here, and then x to top and bottom there. So I got y plus x over xy. Stay, change, flip. And that's x squared y over x plus y. Doesn't really matter to me. Does everyone see the differences? And is everyone starting to understand which one they feel more comfortable with? That's really important. May I continue?
Yes.
Thank you, gentlemen. Okay. I just need to know more or less, how do you guys like me to do it? Method 1? Okay. All right, no worries. What's the LCD of the numerator then, my brothers? 5x. So what do I need to multiply here? Great job, guys. And here? Great job, guys. So I got x plus 5 over 5x. And here's just x plus 5 over 2. Actually, that was a good choice for you guys to choose 1 here. I really think that was a very smart choice. Stay, change, flip. Simplify. An x plus 5 cancels with an x plus 5. My answer is 2 over 5x. Yes, sir, my brother.
In this question, I don't think you will need to, but like the other questions, we can also find the LCD for the bottom part.
Yes, look at number 4. The question was, are you going to have to ever find an LCD for the bottom part? Yeah, number 4. You know, I'm trying to make us walk before we run. Yes, sir. May I continue? Okay. What's the LCD? I'm assuming you guys want method 1 again? What's the LCD for the numerator? Very good. So what do I need to multiply here to this first fraction? That's an x plus. Because I messed up, sorry. And then over here, what do I need? An x. Okay. I'm going to do the math down here, okay? Remember, this is a FOIL, so it's x times x times negative 2, 1 times x, and then 1 times negative 2. So x times x is x squared, minus 2x plus 1x, good job, sir, minus 1x, minus 2, plus 2x, which equals x squared plus x minus 2, right? You guys with me? Over, what's the LCD? Times x plus 1. That's my first numerator of this complex fraction. I'm going to do the bottom in red to hopefully not confuse anybody. What is the LCD of the denominator, gentlemen? X plus 1, x minus 1. Thank you, gentlemen. What am I missing here? What am I missing here? Okay, so let's distribute and calculate it. This is over. I got 3x plus 3 minus x plus 1. Please remember that's a negative. So it's negative 1 times x giving me negative x. Negative 1 times negative 1 giving me a positive 1. Over x plus 1, x minus 1. Right? So that goes here. So actually, wait, let's simplify it. So I got 3x minus x, so that's 2x plus 4 over x plus 1, x minus 1. Is everyone with me so far? Yes, sir, yes, sir. Not yet. Not yet. Hold on. Thank you. The question was, can I factor out the 2? Yeah, we're going to factor out now in a second. Let's just get it raw, and then we'll simplify. Remember, simplify is after divide. Thank you, Papa. Now, to answer your question, you can simplify at any point, but I like to just do it at the end. It's your personal preference. Okay. Let me take this here, guys, real quick. Oh no, that's not gonna fly. No big deal. All right. Now I'll put it all together in black. Let's factor out what we can from here. This is going to be x times x. What times what is negative 2, but we add it together is positive 1. Plus 2 minus 1. Thank you. Over x times x plus 1. So let's stay, change, flip. And now we factor out that 2. Now the fun part. Reduce, simplify. Boom, 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 boom. I can take out this x, right? No, whoever said yes, pay attention. I just tricked you. So this is going to be x minus 1 times an x minus 1, which I can represent as x minus 1, thank you, over 2x. Great job, guys. Does that make sense to everybody? Seems not bad, right? It's a little tedious, but not too difficult. May I continue? Thank you. Okay, now, easy. What's the LCD of the numerator? I'm assuming method one again.
Yeah.
Okay, LCD, y cubed, good. What do I multiply here? And here? Nothing over here, it's just a 1, it's the same. So I got 2y squared minus 8 over y cubed, which would be 2y squared minus 4 over y squared, which, okay, now that we're on this track, 2y plus 2, y minus 2 over y squared. Bam, that's as simplified as I can get it. Yes, sir. Cubed down here. Thank you for that catch. Great job, son. Thank you. Up where? No. That's y cubed, y squared, because I already have a y. I need 2 more y's to get to y cubed. Thank you. Now the bottom. Excuse me. What's the LCD here? Y squared. If I don't have to multiply anything to this, y over y. So this is going to be 2 plus y over y squared. So 2 plus y over y squared. Are you ready to state change flip? No? Okay. I'll wait for a second. Thank you. Talk to me, sir.
Oh, wait, never mind.
Okay, no worries. He figured it out. Good beans. Thank you. The LCD is y squared here. Yes, sir. For the bottom, in the red, the denominator. So stay. Change. Flip. Now the fun part. Bye-bye, bye-bye, bye-bye. So I have 2 times y minus 2 over y. I'm waiting. What's up? Alrighty, guys. Sorry for the interruption. Alright. May I continue, boys? I'm going to erase the work, but I'll leave the answer. Remember, guys, this is a video. You could hit pause. Okay. Let's do it. What's my LCD in the numerator? X plus 2. So I'm going to multiply this. X plus 2 to top and bottom. Giving me 1 plus x plus 2, which equals x plus 3 over x plus 2. Over, what's GCF of the denominator? I mean, LCD of the denominator. X plus 2. So multiply here an x plus 2 to both numerator and denominator. So that's going to give me x squared plus 2x minus 3 over x plus 2, which when factored is going to be x plus 3 times x minus 1 over x plus 2. Now, stay, change, flip. Stay, change, flip. Now, the fun part. X plus 3 cancels x plus 3, x plus 2 cancels x plus 2, and I got 1 over x minus 1. Seriously, guys, no joke. Does that make sense? Yes, sir, thank you. Could I have, no. The question was, could I have left it as x minus 1? No, because that implies that that's in the numerator then. That's a great question, son. Thank you so much. This making sense, gentlemen? May I continue, gentlemen? Okay. Oh, yeah, now we get some good ones. Okay. What do we got here? Very good, son. The LCD of the numerator, I'm going to stick to being completed in blue for the numerator, is 3x plus 5. 3 times x plus 5. So what do I need here? And what do I need here? So this is x plus 5 plus 3, which is x plus 8 over 3 times x plus 5. Now the denominator. Pretty easy. It's just x plus 8 over 9. Now, stay, change, flip. Stay, change, flip. X plus 8 cancels, x plus 8 cancels. 9 divided by 3 is 3, so that cancels out to 3. So it's 3 over x plus 5. Sure. Wait, what do you mean? You're a little confused when you can add? I'm confused with what you're saying. You want me to start over? You want me to start over? Okay, x plus 5 plus 3. Bubble, like terms. 5 plus 3 is 8. Because remember, what's happening here, thank you for your honesty, dude. Look. Thank you. Look. Let me show you. You're multiplying an x plus 5 here. And you're multiplying a 3 here. Well, think about it. The numerator is this. So I got x plus 5 plus a 3. So that's x plus 8 over the 3 times x plus 5. Does that help you? Okay. Does that make sense? All right, let's continue. LCD. This is definitely a method 2 one, though, guys. Okay, you guys are scared of the method 2. Let me show you. What's the LCD of everything? This is an easy one for this. XY. Multiply XY to every single numerator. What's 1 times x plus y? That's xy over x. Plus, what's 2 times xy? 2xy over y. Over. What's 2 times xy? 2xy over x minus, what's 1 times xy? xy over y. Cancels, 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 cancels. I got 2x plus y over 2y minus x. Done. I'll do it method 1 as well. But that's not that bad, is it? Yes, sir. Okay, my boy just said I did it with method 1 and I found it quicker. Good, that's why I just wanted to show you again, just so you won't be scared. Sir? No, that's the whole beauty of method 1. Whenever you multiply by the LCD, it's guaranteed that the denominators are all going to be bye-bye. That's why you're multiplying by the LCD. Thank you, sir. Anything else? You want me to do a method 1? Yeah? Okay, real quick. Method 1. The LCD for both the top and the bottom are the same in this case. It's xy. So here, a y. Here an x. So y plus 2x over y. xy. And then here, same thing, a y and a y. X and an x. So 2y minus x over xy. Stay. Change. Flip. Exact same answer. No big deal. Whatever you like, guys. And ladies out there in the internet world. Anything you want. Does it make sense? Do we have more? Okay. Thank you very much, guys. I hope you learned a lot. Have a great day.